Good day, grade 12 honesty. Praise be Jesus and Mary. Welcome back to our general physics class. It's been a while, my dear students. I hope you guys are doing well. So in this week's lesson, we are going to talk about work, energy, and momentum. These quantities or terms have already been discussed in your module as well as your book. You simply have to refer to the pages stated in your module for the discussion. So what I am going to do in this video is to elaborate the parts or the calculation process for you to be able to follow through or understand better the step-by-step process in the calculation part. Alright, so we will, by the way, before we start, let me remind you that if you have concerns or stuffs you are confused about regarding the discussion or the lesson, or let's say if you need help, please do not hesitate to approach me because I'd be more than willing to help. Okay, so we will start with sample problem 5.1.
Alright, so we will now begin with sample problem 5.1. It states here that a 25 newtons block is being pushed up on a plane inclined at an angle of 30 degrees with the horizontal by 46 newtons force applied parallel to the plane. The block moves 3 meters up the inclined plane. Now, how much work is done on the block by first, or A, gravitational force, B, force F, C, friction force, and D, the last one, is normal force. So these are 4 different forces that act on the block. Alright, so we have here the coefficient of kinetic friction represented by mu sub k, given 0.2. Now, before we start with the solution, we will have first to summarize the given quantities that are useful or that we are going to use in the solution. Alright, so we have here the weight, which is 25 newtons, the angle, which is 30 degrees, force is 46 newtons, and the displacement is 3 meters directed upward. Now, what we need to find here is work done on the block by 4 different forces. I have already mentioned that earlier. Now, since we have already the summary, we can proceed to the solution. In problem solving, analyzation is really necessary. And diagrams and figures are actually of great help in the analyzation process. That is why we have here a diagram or a free body diagram showing the different forces acting on the block. Alright, so for us to better understand and analyze the problem, we have to know first, or to show first, in a diagram, the different forces that are acting on the block. So the red one here is the block, and this line here is the inclined plane, which is 30 degrees. Alright, so one of the forces acting on the block is the gravitational force or the weight, which is given as 25 newtons. This one, this line right here. Alright, this weight is resolved into components which is parallel and perpendicular to the inclined plane. As you can see, we have here component lines. So the component of the weight parallel to the inclined plane is given. Alright, we have here this line parallel to the inclined plane. This is the inclined plane. So this component right here is given as W sine theta. I'm writing this one up here to avoid messing up with the block. Basta kani siya nga line, mao ni siya. And for the component of the weight perpendicular to the inclined plane, we have this line right here. This is the inclined plane. It obviously forms 90 degrees, so that is perpendicular. And for that, we have 25, or that is W cosine theta. Okay, so with that, we have component of the weight parallel to the inclined plane. We have W sine theta. Weight is 25 newtons sine theta. Oh no. 25 newtons sine theta is 30 degrees. And for the component of the weight perpendicular to the inclined plane, we have 25 cosine 30 degrees. Okay, so that's what we have for the weight or the gravitational force acting on the block. Next, we have the normal force. Normal force is right here. Normal force is a force acting on an object perpendicular to the inclined or perpendicular to the plane. So we have this one, F sub n. Alright, now since there is no acceleration along the axis perpendicular to the inclined plane, it follows that F sub n is equal to W cosine theta, or we have, okay, this one, 25 newtons cosine theta. This is W, this is cosine theta. 25 newtons multiplied to cosine theta, we get 21.65 newtons, and that's the value for the normal force. Next is the kinetic friction. For the kinetic friction, small f sub k. Okay, the equation for kinetic friction is mu sub k times F sub n, or the normal force. Coefficient of friction, coefficient of kinetic friction multiplied to the normal force. Right now, the coefficient of kinetic friction is given as 0.2. We multiply that with the normal force, which is 21.65 newtons. 21.65 times 0.2, we get 4.33. Okay, so the kinetic friction is 4.33 newtons. This kinetic friction is located right here in the diagram, because that is the friction produced by the surface of the plane against the block that is being moved upward. Alright, so this line right here. And lastly, we have the force or applied force. Okay, applied force is this one. It is given as 25 newtons according to the sample problem. So we already have here the values, and we have already understood the different forces in the diagram. We will begin now with the calculation. We will start with A, the gravitational force. Okay, we will have to deal with another diagram for this one. And then the weight. Theta. Work done is expressed in equation F displacement cosine theta. All right, since we are dealing with the gravitational force here, we are asked what the work done is. We are asked what the work done by the gravitational force acting on the block. That means we are going to deal with the weight. Our force here, this F right here, will revolve on the value of the weight. All right, so we have to understand the diagram for us to come up with the answer. Okay, so the weight is this one, and the displacement is this line right here. Or we can also have this one, the inclined plane. Okay. So it's time for the substitution. For the force, gravitational force, we have weight. How much is the weight? That was given earlier as 25 newtons. And then displacement is, diba, it is upward. So it's this line right here, and the value or the magnitude is 3.0 meters, and then cosine theta. In this case, since we have already here the theta being used for the first, or the angle of the inclined plane, we are going to use another Greek letter to represent the second angle. So I have taught you before that you can use any other letters. So usually we use the alpha, beta, like that. This time the book uses the Greek letter phi. Now the question here is, why is this angle here equal to 120, which is actually used in the substitution on the next step? I'm going to change this one lang to avoid confusion. So this is phi. Phi and theta are two different letters. Okay, so we will analyze how we came up with 120. Okay, now we all know that theta here is equal to 30 degrees. Okay, so the displacement here can also be, since it is parallel to the inclined plane, we can also treat this line as this line right here. We can come up with the same angles anyway. So, we will focus on this line, ha? Ayaw mo kalibog. Alright, now, so as you can see in your book, there is another angle between weight and the displacement. That angle is represented by phi, which is said to be 120. So we are trying to find out why is it 120. Okay, so from this line right here, okay, this one, and the weight, that is obviously 90 degrees. So 90 degrees plus this one, this angle from the displacement D and the imaginary line, that is what we are going to find out. So, since I have told you a while ago that we can treat this, or we can also treat this line right here, this plane, from here to here as the displacement, we can also move this imaginary line down here. So we can get how much is this, or we can get the value of this angle right here. So I'm going to put the imaginary line. I'm just doing this para mas makasabot mo nga nung ni come up og 120. So in geometry, alternate or opposite angles are equal. So we are going to deal with those angles right now. So this angle right here is theta. And this one right here is its opposite angle. Since opposite angles are equal, theta is equal to 30, right? That means this angle right here is also 30, which has the same value as this Okay, so this is 30 degrees, which has the same, which is also opposite to this angle right here. That means this one is also 30. Okay, so this part here is the same as this angle up here, since we have treated this portion or this line here as the displacement. That means this angle here is equal to 30 degrees. So how did we come up with 120? That is, phi is equal to, what's this one? 90 degrees. 90 degrees plus this one is 30 degrees. Alright, 90 plus 30, we get 120. Therefore, phi or angle phi is 120 degrees. And that is what we use there in our equation, or what we are going to substitute. Okay, and then we will simplify. So 25 times 3 is 75 Newton meter. Cosine 120 times, 75 Newton meters times cosine 120 is negative 37.5. negative 37.5 Newton meter. How did we get Newton meter? That is the product of this unit here and this one here. Newton meter can also be expressed as joules. So we get negative, or we can approximate this one to 38. And this one, we can express that in joules. So the work done is, or the work done by the gravitational force on the block is negative or equal to negative 38 joules. Next is the applied force. This one is much easier. So this is the diagram for letter B in finding out the applied force. So we have here the inclined plane, angle theta, which is 30 degrees, and then the block, the red one here is the block, and the displacement, direction of the displacement, and the force. The force and displacement have the same direction. According to the sample problem given, the force applied is directed upward. That is why the block moves 3 meters upward as well. That means force and displacement here, the applied force and the displacement, have the same direction, which means angle phi in this case is equal to 0. Right, now for the calculation, we have work is F displacement cosine phi. Okay, so our force here is the applied force, which is given as 46 newtons. Naani sa problem ha, ayaw mo kalibog asa ni nako gikuha. And the displacement is still the same, 3 meters. Cosine, what's our angle? That is, the angle between F and D is 0. So, cosine 0. Let us simplify. 46 newtons times 3 meters, that is 138 newton meter times cosine 0. Cosine 0 is equal to 1. Okay, we have 138 newton meters, or 138 joules. Okay, so the work done on the block by the applied force is 138 joules. Alright, next is the work done by the kinetic friction force. Another diagram for this. Oh, what am I gonna do here? The kinetic friction. Another line. Ya, kay puro mani black ron. Basta kadi nga line. That is kinetic friction. Okay, now let us proceed to the calculation. So work done is still F force times displacement cosine phi. Okay, how much is phi here? What is the value of phi here? Angle phi. As you can see, the angle between the displacement and friction or kinetic friction force is obviously 180. Why is it 180? Because the displacement is directed up here and the kinetic friction is down here. It is the perfectly opposite direction with respect to the displacement. It is the perfectly opposite direction with respect to the displacement. Thus, we have 180 degrees. Substitution process. What is our F here? The force here refers to the kinetic friction force, which is, based on our calculation a while ago, we have 4.33. 4.33 newtons times displacement is always 3 meters, and then dili kaigo. Ako na lang i-move diri. Ano ka galisod-lisod, girl? Cosine phi is 180 degrees. Okay, so 4.33 newtons times 3. We have 12.99. That can be rounded up to 13. Oh my gosh. What is cosine 180? Negative 1. Negative 1. So, for the work done on the block by kinetic friction force, we have negative 12.99 Newton meter, or negative approximation 13 joules. Okay, now let's proceed to the fourth one, which is the normal force. Okay, for the normal force, we have another diagram. Okay, and then the displacement, the normal force. All right, so we have work done, F d cosine phi. In this case, the force here is the value for the normal force, which we have calculated earlier. and is equal to 21.65 newtons. Cosine. All right. So the value of phi here, or angle phi, is obviously 90 degrees, since the displacement is directed this way and the normal force is directed that way, and the angle formed between the two of them is 90 degrees. So phi is 90 degrees. Okay. So cosine 90 degrees is equal to 0. Basically, this equation right here will equate to 0. Ako na lang issue. 21.65 times 3 is 64.95 Newton meter times cosine 90, which is equal to 0. Work done on the block by the normal force is equal to 0. That is all for sample problem 5.1. Let's now proceed to another problem.